Hey guys, George at SoundTraxx here. This week we're going to take a step back into basics, and we're going to talk a little bit just about momentum rates, and how they work. So let's get started. So guys, in both our Tsunami2, our Blunami, as well as our Econami and motor decoders, we have a setting in CVs 3 and 4 that are known as momentum. CV3 is our acceleration rate, and then CV4 is our deceleration rate. And what this does is this determines how fast or how quickly the locomotive is going to accelerate or decelerate to the new commanded speed step. So out of the package, when you get your decoders, the momentum rates are set to 0. That way you get an instant start and stop. So just like this locomotive right now, I have no momentum in the locomotive whatsoever. So when I jump to speed step 10, you see that the locomotive immediately jumps to speed step 10, and then when I come to a stop, it instantly stops. That way you get that instant start and stop ability to control your locomotive. However, in the real world, when it comes to our locomotives, they are big, massive pieces of machinery. And they don't start and stop on a dime. They actually take a little bit of time to gain acceleration, or in the case of braking and slowing down, deceleration. So what we're going to do is we're going to go ahead and take our locomotive. Now, CV3 adjusts the acceleration rate. Now, you can adjust this, the value from 0 to 255, and values of 0 or 1 or 2 or lower values correspond to a quicker rate. Higher values will correspond to a much longer time that it takes to get up to the commanded speed. Now, if you go to our user's guide, it basically just gives you that information. It says, hey, if you go use a higher value, it's going to take longer to get there. But the question is always going to become, well, what's the formula? What's the value? How do I know what value corresponds to what? So now if you go to our tech reference, you'll actually see the formula written up. So the formula is written so that the final number you're looking for is speed steps per second. And how do you determine that? Is you take your CV3 value, you multiply that times 0.896, and then divide it by the number of speed steps. Now, in most cases, you'll want to be using 128 speed steps because that gives you the most refined range and smaller increments between individual speed steps. So if I set CV3 to a value of 255, I come up with a value of 1.7 seconds per speed step. So what that means is as the locomotive is accelerating to speed step 10, for example, it may take 17 plus seconds to get to that commanded speed step. And that's just going from 0 to speed step 10. Now, we can go a lot faster by using a lower value, but as I mentioned, CV value of 255 is the highest that you can go. So let's go back and let's use a value of 150. And this is usually what I use on my personal locomotives for my acceleration rate. Now, doing the math, we actually come up with about 1 second per speed step. So getting to speed step 10 would then take about 10 seconds to fully accelerate all the way up. Now, if you try just a nominal value, just a low value, say of a value of 25, now this actually takes 0.17 seconds per speed step. So going to speed step 10 will actually take 1.7 seconds. So you can see how that's going to accelerate a lot faster with a lower number. So let's try this out a couple of ways. So we'll start with CV3. So right now I'm just going to program on the main line here. My CV number 3. We're going to go ahead and jump to speed step 10, and you're going to see that it's going to take 1.7 seconds to get to full speed. So on my NCE throttle here, I'm using this increase fast button. But you can see that it's not instantly starting, but it takes a little bit of time, but now it's already running at speed step 10. Now remember, I have no deceleration momentum programmed in, so we're going to stop instantly. So let's bring our locomotive back. Now we're going to take CV3, we're going to set it to a value of 150. And again, we're going to jump to speed step 10. So you can see how much longer it's taking to get going. Now, one of the advantages is that this allows the diesel engine to actually work more in concert with the speed of the locomotive. So you actually hear that diesel engine rev up to simulate the work that it's going. Now it's actually running at about speed step 10. So the good news is that these rates are adjustable, so you can decide for yourself how fast or how quickly you want your locomotive to accelerate. Now remember, deceleration works exactly the same way, but in the reverse direction. So again, if I take CV4, and we're going to set it to a value of 150. So now I'm going to go ahead and run at speed step 10. You can see that my locomotive takes a little bit to get going. Now we're going to bring it back. Now when I cut the throttle to 0, you're now going to see that it takes a little bit of time to come to a stop. And that's simulating the mass of the locomotive while it's running. Now if you've been watching these videos over the past few weeks, you'll know that this locomotive is actually equipped with a Blunami. Now during the first part of this, I was using our DCC system to actually run and control the decoder. But now we're going to go ahead and connect to the app to show you exactly how to do it using the Blunami. So we're going to go here to settings. Now we're going to go to speed settings. Up here, speed settings, you're going to see our acceleration and deceleration rate. Now you'll notice they're actually set to 150, and that's because the app has already read the CVs to know what they're set at. So knowing that during the first part of this video, we ended up with our acceleration and deceleration rate both at 150. So now using the app, I can simply take this and I can adjust the slider bar and I can set it to whatever I like. Or I can simply type on the number bar and I can type in a value. So if I want to set a value of 50, you can actually see that my acceleration rate is now set at 50. So when I go back to my operation screen, when I start accelerating, you can see that the locomotive now is accelerating at a faster rate. But then when I cut the throttle, you can actually see it takes a few seconds longer to come to a stop because our deceleration is still set at 150. Now guys, for more information on this, be sure to check out the user's guide for the respective decoder that you're using, whether it be a motor decoder, Econami, Tsunami2, or our new Blunami. Be sure to check out the user's guide for all the cool features and how they work together. And in the upcoming video, we'll show you how braking works in conjunction with our momentum rates.